Alright, I'm going to go over Barron free response question 48 here. We started talking about it a little bit in class, or I gave you the opportunity to start in class, and I wanted to have the opportunity to share the solution with you, because I have a few questions. Alright, you'll notice that I highlight the important things I need to know here. Die A has 2 5s, 3 3s, and 1 1 on its 6 faces. Die B has 2 2s and 4 4s on its faces, and it says both dice are fair. Each player simultaneously rolls 1 dice, and the winner is the player with the higher number showing. The question is, which dice would you rather have, A or B? I presented this in 2 ways. First way I did it was down here, and I saw some students do this. I created the sample space. So, what I did was I represented die A in red and die B in blue. So with die A, I could roll a 5. One of the sides is a 5. And then if that happens, then die B could roll a 2, a 4, 4, 4, and I forgot the other 4 because there are 4 4s. And you'll notice I kept going with this. Same thing here. I could roll a 5 with die A, and this would be all the possibilities I could get with die B. I could roll a 3 with die A. I have 3 possible 3s I could roll. And these are all the possibilities I could get with die B. I could roll a 1 with die A, and those are all the possibilities I could get. So what I can do then is I can just count out all the times that die A wins. So if die A rolls a 5, die B gets a 2, die A wins. Same thing here. Same thing here. These are all numbers that are less than 5, which means die A would win. Guess what? The same thing's going to happen over here. Now, if die A rolls a 3, then die B could roll a 2, and in those cases, hey, die A wins. But if a 4 comes up, guess what? Die B would win, so I'm going to take that off the table. And guess what? There happens again. If I roll a 3, 2 could come up with die B. But if a 4 comes up, then I don't win. So now all I have to do is count up all the times that die A would win. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Hey, 18 out of 36, which means that die B would win. Let's see, 1, 2, 3, 4, 5. You get the idea. If I count them all up, I would get 18 out of 36. So according to using this method, it would be 18 out of 36 for either, so it really doesn't matter which one I choose. The other way I did this, I created a tree diagram. You know I like to go with tree diagrams. So what I did was, again, I went with red being die A, 2 out of 6 chance I get a 5, 3 out of 6 chance I get a 3, 1 out of 6 chance I get a 1. And then I used the blue to represent all possibilities I could get with die B. So if I roll a 5 with die A, 2 out of 6 chance that die B gets a 2, 4 out of chance to get a 4. And I just kept this going for every possible roll. And then what I did was I figured out, okay, in this case, die A would win. Right here, die A would win as well. Right here, die A would win. After that, 1 and 4, die A would lose. Die B would win. So die A, again, would lose for 1 and 2. Die A would lose for 1 and 4. And then I just calculated the probabilities. 2 times 2 over 6 times 2 over 6 gave me 4 out of 36. That's why I'm multiplying here. 2 out of 6 times 4 out of 6. That gives me my 8 out of 36. And 3 out of 6 times 2 out of 6 gives me my 6 out of 36. Guess what? If I add them all up, die A wins 18 out of 36 times. Which means die B would win 18 out of 36 times. So ultimately, it doesn't matter which one you choose. Either one has the same probability of winning. So ultimately, which one would you want to, if you want to win, which would you choose? Doesn't matter. Same probability for either of them. Hopefully this helps you solving this problem.